Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good day to everyone. I hope every one of us, each of us is in a very good of health despite the widespread pandemic COVID-19. And please stay safe wherever you are. Please stay safe wherever you are. And I do really hope that this pandemic will be recovered very soon so that everyone can come back to the campus to continue with the face-to-face online face-to-face teaching, inshallah. Okay, for this session or for this video, I will just continue with the next chapter about the breakdown in dielectric. Okay, breakdown in dielectric. Okay, before I continue with the lecture, I would like to acknowledge that this slide is belong to Dr. Makno Ramdon, and I will just deliver my level best to explain or to simplify the content of the lecture, the notes to every one of you. And thank you very much, Dr. for this comprehensive note which made available for all students, inshallah. Okay, what we're going to learn in this topic specifically is general info about the dielectric materials, and then principle in breakdown in gases, liquid and solid. Okay, ionization process in which this is the initiation of the breakdown phenomena. And then we're going to look into the Townsend and Streamer's breakdown principle. After that, we are looking at the post-breakdown phenomena, and then recovery of electric field strength, and not last but not least is about the Paschen law. Okay, these are general about the general outline about the this topic. Okay, what are you going to learn? Okay, what are you going to learn in this topic, as I explained before, and the learning outcome for this topic, for this chapter, will be it is expected that each student should be able to identify and analyze the important elements of breakdown. Okay, this include all the fundamental principle and the phenomena involved related to the breakdown. Okay, on top of that, it is expected for a student to be able to perform high voltage experimental setup. Okay, and to show concern on the safety aspect in the high voltage engineering, which shall be delivered through the project and assignment. Okay, this objective 2 and number 3 shall be delivered through the project and assignment. And what most important for the cognitive part, or for the cognitive part, is the first one is actually for all students to be able to identify and analyze the elements of breakdown, important element of breakdown in dielectric materials. Okay, what is dielectric? Okay, what is dielectric exactly? Okay, I will not read the definition stated here. I will just try to simplify or summarize or clarify to you what is actually means by the dielectric. Okay, in simplest word, dielectric means dielectric is referring to the insulation materials. Okay, insulation material as stated here. Okay, in which as we know, the insulator, the role of the insulator is to prevent the current flow by providing the very high resistance to the flow of current. In which in many dielectric material, in all dielectric material, the electrostatic field will remain almost indefinite. Okay, indefinite. Okay. Okay, obviously when we are dealing about the materials, we are talking about three general state. Okay, gas, solid and liquid state. And the selection of dielectric material, gas, solid and liquid is purely depending on the applications in the high voltage engineering. Okay, the purpose of dielectric materials. Okay, what is the purpose of dielectric materials? Okay, as I explained to you earlier, dielectric is referred to the insulations. I do believe that all of you, which are the final year student, final year electrical student, can actually know what is the function of the insulation materials. Okay, some of them, it is obviously the main purpose of the dielectric material is to control the flow of current between the two conductors, or to be precise, it is to prevent the current flow between the two conductors, or between the conductors and its surrounding material. Okay, it is to provide safety. It is to provide safety to the equipments, to the high voltage equipments and device, as well as the human who are dealing with the high voltage practice. Okay, the desired features of dielectric materials. Okay, when selecting the materials, when selecting the dielectric material for application, engineer will always look for the non-electrical properties as the top priority for each applications. Okay, in this case, for example, okay, gas insulation will be used for the circuit breaker, for example, and liquid oil will be used inside the transformer, and polymeric composite for the insulator core, and the silicon rubber for the insulator shed. Okay, the selection of three type of the gases or liquid or the solid dielectric material is solely because of depending on the applications, and in most cases non-electrical properties will be the top priority in the selecting the correct or the right dielectric state. Okay, in general, the purpose of you should be able to explain the purpose or the function, the role of dielectric material in high voltage engineering. In other words, it is to prevent the current flow. It is to provide the safety to the equipment and human. Okay, we come to the element of dielectric. Okay, as I explained earlier, the dielectric materials important role to separate the electrical potential object with the earth object. Okay, or to provide insulation between two conductor, or to provide the separation between conductor and earth object, either indoor or outdoor. Okay, and there are two main properties, two main elements for the dielectric material. One is, for example, in this case, is the thermal conductivity. Okay, for example, we use the lower thermal conductivity in dielectric materials in preventing the breakdown. Okay, and another example is high dielectric strength. Okay, first we have thermal conductivity, and the second one we have the dielectric strength. Okay, in simplest mean, the dielectric strength referring to the insulation properties, the highest insulation properties that can withstand with the current flow. Okay, that is the strength, that the ability for this material to prevent the current flow. Okay, the thermal conductivity, obviously thermal, we are dealing with heat transfer. Okay, okay, these are the example of the high voltage equipment, which is the transformer, within the transformer, we use the paper insulating winding coil. We use a solid dielectric material to wrap the core of the insulator, and in addition to this, we also use the oil transformer to fill up the tanks, so that to provide additional the required dielectric properties to prevent failure, to prevent damage to the equipments, and to ensure the functionality of the transformer. Here we have the example of solid dielectric material in which it is used for the cable as a insulator, so that the cable is kept protected from the danger of the current flow, the high voltage and current flow. And this is dielectric material in the switch gear. Okay, switch gear, we use the SF6 gas insulator switch gear. Okay, as you can see here, the pipeline here, the pipe here is filled with the SF6 gas, and this is also the outdoor SF6 circuit breaker. So we have this one. In this case, the SF6 is being used for this one for the compact substation, because due to the high dielectric strength. This one, okay. Okay, next. Okay, we also have the example of solid dielectric material in which it's been used for a transmission line. This is what we call as the polymeric insulator. This is the suspension. Polymeric insulator is used to suspend or to hold, to mechanically hold the power line cables or transmission cables here to the tower, to the transmission tower. Okay. Okay, we come to the characteristic and example. Okay, there are some important characteristic of the dielectric materials, in which first we talk about the chemical stability. For example, we have data logger cable insulation in the oil well. Okay, this data logger cable, the insulation cable or dielectric material used for this cable shouldn't be affected by the chemical reaction if immersed in the oil. Okay, so the cable or the insulation should show good chemical stability to ensure the functionality of the insulation materials. And then we talk about the thermal resilience. We discuss about the thermal resilience, in which, for example, in power electronic, we have a very compact device or equipment. We can use silica or ceramic, for example, that can withstand a very high thermal or high temperature, so that to prevent the damage to this equipment. And then in certain cases, we need to use a low density materials in aerial system, for example, blown polyethylene. And thermal conductivity, as explained before, for the transformer, we use oil to allow convection. Okay, we allow convection within the tank. Okay, mechanical strength, polymeric insulator, as I explained before. Again, to provide, it need to have a good mechanical strength, so that the overhead line cable didn't fall down to the ground. Okay, processibility. Processibility means the dielectric material should be processable, or it can be designed, or it can be shaped into the desired pattern depending on the application. Okay, other than that, what most important in selecting the material is about the cost. Cost of, for example, we have air as insulator, gas insulator, versus SFC gas insulator. These two material can possess the same characteristic of dielectric, but when talk about on the cost implications, SFC will cause a huge financial implications, in which this gas, you need to pay for this gas, and at the end, after a certain period of time, the gas will be disposed, and to avoid the environmental effect, and again you will be charged for that, okay, to dispose the SFC gas. This is what the some of the issues, environmental issues related to the SFC gas. And low smoke emission. Okay, low smoke emissions, obviously we are in this recent world, we are talking about low carbon emission. The priority is for the materials that can actually produce a lower carbon emission compared to the conventional device. For example, we compound the polymer with the ATH. This is a filler that been used to reduce the carbon flow. Okay, now we come to the problem of the dielectric. Okay, problem of the dielectric. Okay, in general, all I can say, the problem with the dielectric is about the breakdown. Okay, that is what we're going to learn in great detail in later section. But in general, you can obviously read all these texts. I don't need to explain it again. But in general, the problem with the dielectric is the breakdown of the materials, in which there is some external factor and some intrinsic factor that promote to the breakdown. When we talk about the breakdown, it means the malfunction of the dielectric material to serve as insulator. This is very serious issues, and this is the failure in the dielectric material, which may lead to the failure in the high voltage applications. And obviously the breakdown of the level of the breakdown can be depends on the internal material, chemistry, or physics bonding. It depends on various factors such as electric field, stress, temperature, and environmental effect. Okay, we will discuss in great detail of the breakdown of dielectric material in gases, solid, and liquid in the next section.